Electric motors can be divided into a number of different types based on the structure of how they're driven. AC motors are driven by alternating current. By stepper motors rotate in fixed steps each time a pulse of electric power is input. The DC motors are driven by direct current. Compared to the other types, the benefits of DC motors include being able to operate at high speeds and delivering high starting torque. DC motors can be further divided into brushed motors and brushless motors. The operation of a brushed DC motor is based on the mechanical linkage between the commutator and the brushes. Brushless DC motors, on the other hand, do not have a commutator and brushes, and instead are electronically controlled with a drive circuit. The main features of a DC motor are as follows: ability to operate at high speeds and high starting torque, which means these can be used in applications that do not need lots of torque, like in really big mechanical machines. These motors would not be used. These will be used in smaller applications such as an RC boat truck or something, or a car. A specific feature to the brushed DC motor is that they do not require a drive circuit in applications where the speed control is not needed. The speed control is basically it tells the motor how much power is supposed to be go in. As a brush motor has brushes, so it knows all the time. But something like a brushless motor doesn't have brushes, so there needs to be a speed control to know so the correct amount of power can go in, or else there's no regulator. And if there was no speed control and was directly connected, the motor would probably die because it wouldn't be able to it wouldn't be able to spin as much power that was given. Brushed DC motors are further divided into two types: permanent magnet motors and electromagnet motors. Permanent magnets are motors which use permanent magnets to generate the magnetic field. Are the most common form of electric motors used worldwide, being used in toys and models, and also the auxiliary motors of automobiles. They have a permanent magnet stator and coils for the rotor. Electromagnetic motors, on the other hand, use electromagnet to generate the magnetic field. These are more expensive, and they further divide into two types: series wound and distributed wound, and separately are different from permanent magnet motors. These motors, depending on how the field winding and armature winding are coupled, they are widely used in sizes and ranges from medium-sized electric motors to around 1 horsepower large motors. Brush motors work really simply. Brush motors have coils in the rotor which are surrounded by magnets contained in the stator. The two ends of the coils are connected to the commutator. The commutator in turn connects to electrodes called brushes, resulting in the flow of direct current electric power through the brushes and coil for as long as the brushes and commutator are in contact. As the coil rotates, however, it reaches a position where the brushes and the commutator are no longer in contact, halting current flow in the coil. Despite this, the momentum of the coil causes it to continue rotating. This brings the brushes on the commutator back into contact, restoring the current that now flows through a different coil. Maintenance is necessarily needed for DC motors as the way they work. The brush motors require brushes as the rotation of the coil causes the contact between the commutator and the brush to alternate, therefore switching current as there's flow through the coil. As a result, the brushed DC motor can operate. Despite its simple structure, the continual contact between the brushes and the commutator, the motor rotates causes wear, and this creates needed for regular maintenance to replace worn parts. But with brushless motors, the commutator and the brushes do not touch. In fact, there is no brush. In fact, there is only a permanent magnet and four different electromagnets surrounding it, so nothing touches. So there's no wear.